Hi, in this session, I'll be showing how to model a thin rod under tension. I'll be using COMSOL 4.3 for this demonstration. So to begin, we open a new file and we'll be modeling it in a 2D axisymmetric mode. We'll click Next and we'll choose Solid Mechanics. It'll be under Structural Mechanics and Solid Mechanics. Hit Next. As you can see, it adds it. And we'll be doing a stationary or time independent solution. And we'll hit finish. I'll define first some global variables. So under global definitions, I'll right click, choose parameters. Parameters are for constant while variables are more for equations. So I'll be choosing parameters. And under name, I'll define the radius as rad, 1 centimeter, and a length as 25 centimeters. So under geometry, just to show you, you can change the units that you'll be working with here to make your life easier. And you can change it to a variety of units. And for today, I'll just be choosing centimeters. So under geometry, I'll be drawing a rectangle, and once it's revolved around the r equals 0 line, it'll turn into a thin rod. So for width, I can use the predefined parameter that I use as my radius, and as the height, I'll just type in length. And I'll hit build, and you can see there, it's once revolved, it'll be a thin rod. Alright, so for my next step, I'll choose copper as my material. It's under built-in copper. Hit the plus to add it. Adds it and automatically chooses the first domain. Just to quickly check, you see that there's 3 green checks, meaning it has the necessary material constants for the solid mechanics. It has the density, bulk modulus, and the Poisson ratio. For our physics, we'll need to define some boundary conditions. There's already, it assumes a linear elastic material. If you click equation, you can see the set of equations that it'll be solving for. It assumes axial symmetry along boundary number 1, as you can see here, while the rest of the boundaries are assumed to be free or no stress, and some initial values pretty much of 0. So I'll be first defining a symmetry boundary as z equals 0. So you can left click on the boundary, and you can either right click to add it, as you can see there, or you can hit the plus to select it. Now this assumes that my rod will be it's a symmetrical rod, so in fact the total length of my rod will be half a meter, since this length right here is 25 centimeters. Now at my other boundary, I'll be adding a boundary load, so I can put it under tension, and I'll be clicking boundary 3 and right clicking on it, and I'll leave it as load defined as force per unit area. Now if you click on it, there's 3 other different types of forces you can place on it. Load defined as force per unit area allows you directional, so it can be either into it or at some different angle. Total force is in units of force, while pressure is always assumed to be inward. So since we're going to place this under tension, I'll leave it as load defined as force per unit area, and for z, I'll put in just 10 Pascal in the positive Z direction. So for mesh, I'll just choose a slightly finer mesh, and you don't have to build the mesh. You can simply under study hit compute, and it'll build it automatically for you. So you see there it's finished pretty quickly. I'll hit the zoom extents button just to kind of get it into focus or get into view, and automatically it loads some predefined plots for you. You see a 2D of the stress, and it also has a 3D picture of the stress. So here the stress, although you see some different colors, make note of the scale. It's pretty much all 10, which is exactly what a rod in equilibrium should be, since we applied only 10 Pascal of force. Now say we want to see the displacement of our rod. So to see that, you can add a plot yourself. So I'll be adding a 3D plot group. And then under this plot group, you can plot multiple plots. So I'll right click again, but I just want the surface, a surface plot. And under here, you can choose a variety of different physics that's already calculated for you, or properties of the geometry. But in this case, I want to see the displacement, which is solid.disp in units of centimeters. So I'll hit plot, and there you see the displacement of the rod. So you can see here, right where we had a symmetry boundary, it doesn't move as it should, and at the end it extends the most. Okay, so we can, you can play around with what exactly parameters you want to see. But now I'm going to repeat this, except with the load in a compressional mode, in a compressional direction, I'm sorry. So I'll just simply flip or add a negative to a negative Z direction to my force or my pressure, and I'll compute that. And you can see here the blue is, in this case, the rod is compressed as well. And you can see here it's displaced as well. So there you go. Hopefully that helped.